Your hairline started forming before you were born. In the womb, weeks before you had a face anyone would recognize, a set of genetic signals was already drawing a map that points directly to where your ancestors survived. Here's what nobody tells you. Your hairline isn't a cosmetic feature. It's the front line of a solar shield your lineage spent 2 million years engineering to protect the most expensive organ in the human body. From the northern seeker to the androgen heir, there are 8 specific shapes. And if you have shape number 5, your lineage solved a problem most humans never faced. High hairline, the northern seeker. You've probably heard your whole life that a high forehead looks distinguished. That framing is recent. For most of human history, it was just biology doing its job. A high hairline means a larger exposed forehead, more bare skin between your brow and your hair, and your skin is basically a solar panel for vitamin D. The more of it you expose to sunlight, the more your body can produce. In places where the sun barely shows up, Northern Europe, Inland Asia, the northern reaches of the Americas, that mattered enormously. Your ancestors didn't have the luxury of year-round sun. 6 months of weak winter light. Vitamin D deficiency wasn't a wellness concern. It was a survival risk. People living where the sun rarely shines needed every patch of exposed skin they could get. Researchers propose that reduced scalp coverage in these populations reflects a direct response to that pressure. In equatorial Africa, confirmed research from PNAS shows that scalp hair evolved specifically to block solar radiation and keep the brain cool. But move north, and that equation flips entirely. Less hair coverage at the front means more forehead skin exposed, means more vitamin D produced through the limited daylight hours available. The trade-off is real. A higher hairline gives you less shielding across the top of the skull. In strong sun environments, that's a genuine liability. But in a Norwegian winter, nobody was complaining about too much UV. Your ancestor wasn't distinguished. They were cold, and they were solving it. Rihanna has it. Leonardo DiCaprio has one of the most photographed high foreheads in Hollywood. None of them built careers in spite of it. The feature that got your ancestor through a Scandinavian winter turned out to look pretty good on a red carpet, too. But if a high hairline is about chasing the sun, a low one is about surviving it. Low hairline, the solar sentinel. A low hairline sits close to the brows. The hair begins early. It covers more of the skull, and it does that on purpose. Read that again. Your scalp hair is a solar shield, and a low hairline is the maximum coverage version of that shield. The 2023 PNAS study confirmed this with actual thermal testing. Researchers used a thermal mannequin, essentially a human-shaped heat sensor, and found that scalp hair directly reduces heat gain from solar radiation. More coverage means less heat reaching the brain and less sweat the body has to produce to compensate. In equatorial Africa, South Asia, and Central America, under direct sun for 12 hours a day, that was the difference between a brain that kept working and one that didn't. Here's what that actually looked like for your ancestor. Noon in the savannah, and temperature above 40 degrees Celsius. So no shade for miles. The hair didn't retreat because it didn't need to. It stayed close to the forehead because every centimeter of coverage reduced the thermal load on the most critical organ your lineage was running. The hair didn't retreat. It held the line. The trade-off. More frontal coverage means less forehead skin exposed to sunlight, which means less surface area acting as a solar panel for vitamin D production. In low UV environments, that's a real cost. But in the environments where this hairline became common, vitamin D was never the problem. Too much sun was. That's the equatorial story. Maximum coverage, maximum protection. But some hairlines aren't about coverage at all. They're about precision. Linear or straight, the stoic guardian. The linear hairline cuts clean across the forehead. No peaks, no curves, just a straight horizontal line. Here's what most people don't know about that line. It's not the absence of complexity. It's the result of 2 opposing embryonic forces canceling each other out, almost perfectly. During fetal development, hair follicle growth is actively suppressed in a pair of symmetrical fields above the eyes. Those suppression fields grow inward from both sides. Where they meet, and how evenly they meet, is what determines the shape of your hairline. A clean straight line means they matched with near-perfect bilateral balance. Neither side dominated. Neither side failed. They converged exactly. Evidence suggests that this kind of symmetry reflects how smoothly your body followed its original blueprint during development. Researchers who study what's called fluctuating asymmetry, the small random deviations that appear when development gets disrupted, consistently find that more symmetrical features signal lower developmental stress during formation. A straight hairline is about as symmetrical as a hairline gets. What that likely meant for your ancestor was a gestation with relatively low environmental interference, good nutrition, stable conditions, a body building itself without significant disruption. That's not a guarantee. It's an inference from developmental biology, but the clean line is evidence the signals that shaped your hairline ran without noise. The trade-off: a perfectly straight hairline is the middle position, neither the maximum UV coverage of a low hairline nor the maximum vitamin D exposure of a high one. It sits at the population average, which, in evolutionary terms, is often exactly where you want to be. Symmetry is safe, but as we're about to see in the bell shape, sometimes your hairline is forced to follow the literal architecture of your skull. Round or bell-shaped, the harmonic voyager. The round hairline doesn't cut across the forehead. It follows it, curving down on the sides, tracing the natural arc of the skull beneath. Skull morphology is one of the most well-documented areas of population variation in all of physical anthropology. Populations from different ancestral environments show measurable differences in cranial shape, rounder, longer, wider, the accumulated result of thousands of years of selection, genetic drift, and adaptation to specific climates and altitudes. A hairline that curves rather than cuts tends to appear where the underlying cranium curves rather than flattens. Evidence suggests that rounder cranial profiles are more common in certain African, East Asian, and indigenous American lineages, populations whose ancestors lived under environmental pressures that researchers still actively study. What isn't in dispute is that skull shape and hairline shape develop together. They're not independent. The hair follows the bone. Think of it this way: your hairline isn't just sitting on your head. It's wrapping around a structure that your bloodline spent generations refining. The curve in your hairline is a surface echo of the curve in your skull, which is itself a record of where your ancestors lived and how their bodies adapted. Functionally, a round hairline extends the solar shield slightly toward the temples, adding lateral coverage that a straight line doesn't provide. In populations from high sun environments, protecting the sides of the forehead mattered too. The trade-off mirrors the low hairline: more coverage, less vitamin D surface area. But the round hairline is less about a standalone decision and more about the whole system: skull, hair, and coverage, being shaped together over time. Now, before we get to the most controversial shape, the widow's peak, check your own mirror. If your hairline does this, you've been told a lie about your genetics for years. Widow's peak, the ancient cartographer. A lot of people confuse this one with the M shape we're about to get to. They're not the same thing. One is hormonal, driven by testosterone byproducts that show up in adulthood. This one was set before you had hormones, before you had a face. It's a different story entirely, and it starts with a lie you were probably taught in school, that the widow's peak is controlled by a single dominant gene. That is one of the most repeated myths in basic genetics, and it's wrong. Ancestry DNA researchers surveyed over 990,000 people and identified more than 840 separate DNA markers associated with widow's peak hairlines. Not one gene, not two, 840 markers spread across the genome, all contributing to whether or not that V forms at the center of your forehead. Here's what actually creates it. You already know about the suppression fields from the linear section, the two embryonic fields that grow inward from both sides and determine where your hairline lands. In most people, they meet cleanly. In a widow's peak, they don't fully reach the center. There's a gap, and in that gap, where the signal to stop didn't arrive, the hair keeps growing downward, forming the V. Read that again. The widow's peak isn't extra hair growing forward. It's the region where the signal to stop didn't arrive in time. What does that tell you ancestrally? This is a developmental variant, polygenic, appearing across diverse populations worldwide, without the strong geographic clustering you see in nose shape or eye morphology. Between 30 and 40% of people globally have some degree of widow's peak, across every continent. What it does correlate with is family. Your suppression field geometry came from your parents, and theirs came from theirs. The trade-off is structural. The V creates more coverage at the center of the forehead and less coverage at the temples. Whether that mattered to your ancestors depended on exactly where they lived and how intense the sun was when they got there. Keanu Reeves has one, Marilyn Monroe had one, and reportedly had it removed by electrolysis when she became famous, which says everything about how wrong the culture got this feature. Britney Spears, Nick Jonas. The list of people carrying 840 markers of polygenic complexity on their forehead and doing just fine is very long. The widow's peak tells you something about your embryonic wiring. The next shape tells you something about your hormones. And the biology is more surprising than most people expect. M-shaped, the androgen heir. The M shape is the one people worry about most. Two receding points at the temples. A center that holds while the sides pull back. It looks like the beginning of hair loss, and sometimes it is, but sometimes it isn't, and the difference matters. The M-shaped hairline has two completely separate origins. The first is a mature hairline, a normal developmental shift that happens in most men between their late teens and mid-20s. The juvenile hairline of childhood, sitting low and even, transitions to an adult one. The temples recede slightly. This is not hair loss. It's puberty finishing what it started. The second origin is genetic sensitivity to hair-thinning hormones, specifically dihydrotestosterone, or DHT, a byproduct of testosterone. DHT binds to androgen receptors in genetically susceptible hair follicles and causes them to shrink until they basically disappear. The key gene is the AR gene, located on the X chromosome, which men inherit from their mothers. Variants in the AR gene produce receptors that respond more aggressively to DHT, making certain follicles more vulnerable. This is why the pattern often traces through the maternal side of the family. But here's the part that changes how you read this. Men with this genetic profile statistically tend to have higher baseline levels of free androgens, including testosterone. The cheat code and the cost live in the same gene. The ancestral environment where this made sense was one where higher androgen levels conferred real advantages in younger bodies: physical competition, immune resilience, faster stress response, and where the follicle cost didn't show up until well after reproductive age. Your ancestor wasn't losing that trade, they were winning it. The thinning temples came later. The trade-off is the most documented in this script. The same hormonal profile that may drive real advantages in your 20s creates follicle vulnerability in your 40s. That's not a flaw in the design. That's the design, reproductive age benefits, paid for by post-reproductive costs. Jude Law has it. Harry Styles has it. Chris Hemsworth, Thor himself, has an M-shaped hairline and has never once looked less like a person who won a genetic lottery. The temples didn't end their careers. The biology behind those temples might actually explain part of why they're built the way they are. Some shapes are hormonal. This next one goes even deeper, back to before the hormones even existed. Triangular, the convergent architect. The triangular hairline tapers, wider at the temples, narrowing toward a point near the center, angles more gradual than a widow's peak, peak wider, usually sitting higher on the forehead. Like the widow's peak, this shape comes from those same embryonic suppression fields above the eyes. But the story is slightly different. In the widow's peak, those suppression fields didn't fully reach the center, leaving a gap where the V forms. In the triangular hairline, the fields did converge, but not evenly. One side pulled slightly stronger, or the fields met at a wider angle. The result is a gradient. More hair coverage at the center, less at the lateral edges, but with a softer geometry than the sharp V. Think of it as a widow's peak that almost resolved, a suppression process that went further but didn't quite produce the straight line either. It's the intermediate outcome of a cascade of gene expression events during fetal development that laid down where follicles would activate and where they wouldn't. What does that tell you ancestrally? Like the widow's peak, this is a developmental variant with polygenic roots, appearing across diverse populations without strong geographic clustering. What does cluster is family. Triangular hairlines run in lineages not because one gene is driving it, but because the whole constellation of genes that shapes those suppression fields gets passed down together. Your parents handed you their field geometry. Their parents handed it to them. The trade-off mirrors the widow's peak: less lateral coverage, more temple exposure. In high UV environments, that was a real cost. In temperate ones, less so. The temples were just getting slightly more sun than the rest. All 7 shapes so far have been about the world outside, what your hairline does to protect your brain from the environment. This last one is different. This one is about the world inside your head. Cowlick or uneven, the lateralized pioneer. So far we've looked at how your hairline protects your brain from the outside. But this last shape, the cowlick, is actually a signal of how your brain organized itself on the inside. Your hair grows in a direction your parents didn't choose and you cannot change. From the moment those follicles were laid down in fetal development, their growth angle was fixed. The result is a swirl, a wave, an asymmetry, something that won't sit flat no matter what you do to it. Most people spend years fighting it. Here's what they don't know. Research published in the journal Genetics, led by Amar Klar of the National Cancer Institute, found that scalp whorl direction, the clockwise or counterclockwise spiral that drives cowlick formation, is linked to the same genetic mechanism that determines handedness. Among right-handed people, clockwise whorls dominate. About 92% of right-handers swirl that way. Among left-handed and ambidextrous people, it's essentially random, roughly 50-50. The same underlying gene appears to influence both brain lateralization and hair follicle growth direction. Your cowlick is, in part, a surface print of how your brain decided which hemisphere would lead. Note, Modern genetics has complicated whether a single gene drives this entirely, and the relationship is probabilistic, not a certainty in either direction. But the link between whorl direction and brain lateralization is real and replicated across multiple studies. You are not imagining the connection. It's in the literature. As for the irregular wave or uneven hairline, scientists studying developmental asymmetry, the small random deviations that appear when fetal development encounters disruption, find that greater asymmetry correlates with greater developmental stress during gestation. Nutritional, environmental, immune. A slightly irregular hairline isn't a defect. It's a record. It says your development ran into turbulence and still built you anyway. The trade-off. A disrupted growth direction slightly reduces the uniformity of the scalp's solar shield. In high sun environments, even coverage distributes UV protection more efficiently. But the cowlick is there because the brain lateralization mechanism was selected for the capacity to have a dominant hemisphere, a dominant hand, a specialized brain. And the swirl in your hair is just what that choice looks like from the outside. Every hairline in this video is a variation of one thing. The southern boundary of a solar shield your lineage spent 2 million years refining. The brain is the most metabolically expensive organ the human body has ever built, keeping it cool under equatorial sun, protecting it from UV damage, keeping forehead skin available for vitamin D production through 6 months of northern winter. Those pressures played out differently in every latitude your ancestors moved through. The hairline moved with them, and none of this is fixed. Hairlines shift with age, hormones, and stress. What you have at 25 may not be what you had at 12 or what you'll have at 50. The feature is dynamic. The ancestry it points to is not. Does this track with where your family actually comes from? Drop your ancestry and your hairline type below. The geographic patterns in the comments on these videos are always worth reading. I am Noah, and I'll see you in the next video.